All right, let's dive in. Today, we're going to pull back the curtain on this, well, kind of invisible structure that organizes our entire digital world. And no, it's not code, it's not the internet, it's something way more fundamental. It's the mathematical language that makes all of that stuff work.
So, let me ask you a question. What could a spreadsheet, that photo you just liked on social media, and the crazy smart AI that recommends your next movie possibly have in common? I mean, on the surface, they seem like they're from different planets, right? Well, it turns out they all share the exact same hidden backbone.
And that backbone, it's linear algebra. Now, don't let the name scare you off. This isn't going to be some dry math lecture, I promise. It's actually a super elegant, kind of beautiful way to organize information. And the best part? It all starts with something you use every day, a simple list.
So, let's start with that first, most basic building block. We're going to call it the vector. And a great way to think about it is as the fundamental atom of all information. So what is a vector, really? It's just a list of numbers. That's it. Each number in that list represents a specific characteristic, or what we call a feature, of one single thing, one data point.
Let's make that real for a second. Imagine we're looking at data for one customer, okay? This person is 25 years old, they have an income of $5,000, and we've given them a spending score of 80. Those three numbers, age, income, spending score, those are the features that describe this one person.
And in the language of linear algebra, we take that information and we just write it like this. A simple, clean list of numbers inside some brackets. That right there, that's our vector. It captures everything we know about that single customer in one neat little mathematical package.
Okay, so once our data is in this vector form, we can start doing some really powerful stuff. We can add vectors to combine data from two people, or we can multiply them to scale their features up or down. But here's the really cool part. We can measure how similar two vectors are. This is literally the magic behind things like Spotify or Netflix recommendations. An operation called the dot product basically calculates a similarity score between your taste vector and the vector for a song. High score? Boom, it gets added to your playlist.
All right, so a vector is one data point. That's cool. But what happens when we've got hundreds, or thousands, or millions of customers? Well, that's where we zoom out from a single point and start to see the full picture.
We just stack them. It's that simple. You see how each row is just a new vector for a new person? Suddenly our simple list has turned into a table. And that format should probably look pretty familiar to you.
Yep, that table has a name. It's a matrix. It's just a collection of vectors, all nicely organized in rows and columns. So here's the biggest takeaway so far. If you've ever used a spreadsheet, you already, intuitively, understand what a matrix is. It's just a container for a whole dataset.
And this is where the power really kicks in. See, matrices aren't just for looking at data. They let us work with the entire dataset all at once. We can use them to organize everything, to transform it, like, say, rotating a digital image, and even to automatically extract the most important features for a machine learning model.
One of the most important operations is called matrix multiplication. Now, we're not going to get bogged down in the math, but the idea is that it combines all the information from the rows of one matrix with the columns of another. It's a really systematic way to transform data and create totally new insights that were hidden before.
So, we've gone from a 1D list, the vector, to a 2D table, the matrix. But what if our data is even more complex than that? I'm talking about a color image or a video clip. This is where we step into the language of modern AI.
And that next level is the tensor. The best way to think about it is as a natural extension of everything we've just learned. If a vector is a list and a matrix is a table of lists, well, a tensor is just a stack of tables. It's how we organize data in 3 or 4 or even more dimensions.
Let's just visualize that for a second to make it stick. A vector is like a single row of dots. A matrix is a flat grid of dots. And a tensor? Well, a tensor is like a cube of dots. See that? Each new dimension just lets us stack another layer of related information.
So why do we even need this? Why do tensors matter so much? Because the real world isn't flat. A color image isn't just a 2D grid. It has height, width, and 3 color channels: red, green, and blue. That's a 3D tensor right there. A video just adds another dimension: time. Tensors are the only structures that can handle this kind of complexity, which is why they are the absolute foundation of deep learning and neural networks.
Okay, let's bring this all home. We've gone on a pretty quick journey from a simple list of numbers all the way to the complex data structures that power today's most advanced AI.
And the entire journey is really this simple. We started with the vector, just a single list. We stack those vectors on top of each other to create a matrix, which is really just a table. And then we stack those tables to create a tensor. See? It's just a simple, logical progression of building blocks.
So if you take one thing away from this, it should be this. Linear algebra isn't some scary, abstract math you'll never use. At its heart, it's just a really powerful, really elegant system for bringing structure to the chaos of data.
And that really brings us to the final thought. Now that you can see this hidden structure behind almost everything in our digital world, the vectors, the matrices, and the tensors, it kind of makes you wonder, right? What will you build with it?